The topic of today's webinar is integration between pSeven and PTC Creo. This is new functionality appeared in the last version of pSeven 4.0, that was released 2 weeks ago. The webinar consists of two parts. The first part will be the presentation where I tell you about our product pSeven, CAD system PTC Creo, and how they can be used together. The second part will be live demonstration where I show you how these new integration capabilities can be used for solving real engineering problems. At first, a brief description of pSeven. pSeven is an integration platform that allows to automate engineering calculations. Usually, engineer has to use several different applications when solving the problem. Some CAD system, CAE system, a solver, mesh builder, post-processor. Sometimes, to couple all of this together, scripting languages are used, but it requires time and programming skills. pSeven allows to do the integration easily in few mouse clicks and is capable to do many things that engineer generally needs, but they are not so easy to program. Things such as remote launch of the calculations, parallel execution, reusing of previously calculated configurations, etc. Apart from integration capabilities, pSeven includes powerful optimization and data analysis algorithms. The main feature is the automatic selection of most suitable technique based on high-level options and problem description. So engineer doesn't need to know peculiarities of a specific algorithm to choose one, and doesn't need to make it low-level tuning. Now some words about PTC Creo. Creo is a suite of product design software developed by Parametric Technology Corporation. The suite consists of several applications. Creo Parametric, formerly known as Pro Engineer, which is a 3D CAD application. Creo Simulate, which is a CAE application for structural and thermal analysis. Creo Direct, Creo Illustrate, Creo Schematic, Creo Sketch, and others. Today, we consider an integration with PTC Creo Parametric, a CAD part of PTC Creo. Now I'll try to answer the question, why we need pSeven if PTC Creo has its own solver, I mean Creo Simulate, and also has some embedded optimizers. So why we need integration if all calculations can be performed inside Creo itself, and why we need all these algorithms also? The answer is that these embedded capabilities are not enough. Generally, embedded CAE, like Creo Simulate or SolidWorks Simulation, are the tools for some quick and preliminary analysis. When solving real problems, external solvers like Ansys Mechanical are usually needed. It's especially true for multidisciplinary problems, which may contain, for example, strength analysis, thermal and gas dynamics, and other calculations that have to be bundled into a single model. As for the embedded optimizers, they use rather simple algorithms, so pSeven optimization algorithms are more effective. Also, pSeven has techniques such as surrogate-based optimization, robust optimization, uncertainty quantification, multi-fidelity approximation, and there is no CAD system that have such advanced embedded algorithms. For those who attend our webinar for the first time, briefly say how the user usually works with pSeven. The engineering problem described with so-called workflow in pSeven. The workflow consists of blocks. For example, there is block of integration with Creo, block for optimization, cycle block, condition block, etc. Blocks may receive data and write data to its input and output ports. For example, the simple calculator block that multiplies two numbers will have two input ports and one output port, where it will write the result, and where this result will go further is depend on the links between blocks. The links is a data channel that connects blocks and set the sequence of its execution. The workflows in pSeven are hierarchical, so they can have the nested structure. The projects in pSeven consist of several workflows. the typical sequence of actions that user do when solve the problem. It create the workflow, add blocks, configure it, and set links between them. Then choose the input data for the launch of the workflow, and also he choose the data that should be saved during the execution for the further analysis. After the workflow finishes, data can be analyzed and visualized using plots, tables, and statistics. Now we go to the integration block with PTC Creo parametric. For the model of Creo to be used inside our workflow, user need to choose what characteristics of the model will be changed during the workflow execution, and also what data should be extracted from the model for further using in another block. For this, in the configuration window of the block, we can choose the model and build a tree of its characteristics. This tree contains dimensions, in all dimensions inside all elements of the model, and also the parameters, and also the mass characteristics like volume, mass, area, the center of mass, and the moments of inertia. All this data can be used inside the workflow. For every characteristic inside the block configuration window, user can see its current value. Block supports both parts and assemblies. The tree for the assembly contains all the dimensions in all parts, and also mass properties of not only assembly but all parts. On the slide, you can see the assembly with the model of a hand that contains some parts. For example, the finger part, and the tree has this finger parts and features and dimensions of this part, and also the mass properties of the assembly itself and the mass properties of the parts that are inside this assembly. Then, in the tree, user can choose necessary dimensions, parameters, and mass properties, and map them to the input or output ports. On the slide, you can see the configuration window with the tree and 6 dimensions map to the input ports, and also the mass map to the output ports. During the calculation, during the workflow run, some values will be passed to the block, and these values will be set to the dimensions, and model will be regenerated, and after each recalculated value of the mass will be written to the output ports. Apart from this, the block can export regenerate model to different formats. Then exported document can be passed to the solver or CAE system. Also, Creo block can save the model into this format. So, for example, after the optimization finish, the optimal model can be saved to the disk. Sometimes, when some values are passed to the model cannot be regenerated with these values. So user can choose what pSeven should do in the case of regeneration failure. So there are 2 alternatives to stop the workflow if the user thinks that this cannot be. So in case of such values, the workflow should be stopped, or to write some default values to the output ports. Usually, the block uses NaN, not a number values, as this default value. And then these NaN values can be passed directly to the optimizer block, and the optimizer can handle with this value. So for the optimizer, this not a number values means that the objective function or constraint cannot be calculated in this point. Apart from this, pSeven can handle with Creo parametric fail or hang or restart. So in case of application shutdown, the pSeven just restart the Creo parametric and proceed with the workflow with the optimization. And also the block has the visibility option. So if it's false, Creo will be run in background, and if it's true, it will be run with graphical interface, so user can see how the model is recalculated and regenerated. In pSeven 4.0, apart from Creo blocks, there are also blocks of integration with SolidWorks, Compass 3D, and Castia version 5. They have capabilities similar with Creo block. In the next version of pSeven, we plan to add the integration with CAD systems Autodesk Inventor and Siemens NX. So these blocks are under development now. Soon we will go to the live demonstration, and first I will tell you briefly about the problems that we want to solve.